Drew Nabb here. Today we're going to cover wheels and tires. Basic function of a tire. Tires obviously have to grip the road and they provide the friction between the ground and the car. But also tires provide vertical spring rate. You drop the tire, you've seen it bounce, you can see it's clearly a spring. It's a portion of the actual wheel rate of the car. Also, tires give us an opportunity to change the balance of the car by changing the pressure of the tire or the actual conditions the tire is presented to the ground by changing the camber, toe, etc. Now, for the ChampCar series, we have to run tires that are 180 tread wear. And if you look on the inside of most tires, there'll be a number that will give the UTG rating for tread wear. That will also be what tech uses to verify your tire meets requirements. There are several vendors that offer performance tires well suited to ChampCar. Maxxis is one of them. And you'll find that there's information for all these tires on the web. Everybody has their own favorite tire. But for the most part, the tires have to provide wear rates acceptable to endurance racing, 7 to 14 hours. There are some tires that meet our requirement that will not survive that. So look online, look on the forums for advice, ask your buddies, attend a race and look around and see what the podium cars run on. Those are all great sources to get you a tire that will finish the race and give you a trouble-free weekend. So how do you pick a particular size tire? You go into a race, you looked online, you determine what brand of tire you want, and perhaps even what model, what size. So the most important factor on size is going to be the diameter. And you need to see what tire was originally offered in your car and figure out what the overall diameter for that tire was. A great resource to look up, go to TireRack.com, enter in your tire's overall diameter, and you can search for other ones like it, or find your diameter by entering the tire information for your tire. After you begin to search for tires with the correct diameter, then I would look for the correct width. Diameter, though, still is the most important factor, and for example, this tire that's off of a SLK would in no way fit my Neon or Miata, which have nearly a 3-inch smaller outside diameter. After you've picked a rim width and a wheel overall diameter, then you can look for tires that have a particular rim diameter, because you can pick any rim diameter you want when you go to buy wheels in the next step. So an important consideration when you're thinking and talking about tires. Tires are actually springs. So this tire is still inflated, and if I even drop it a little bit, you can see it bounces. It actually acts like a spring. This tire underneath, however, has been deflated. So this one you can actually see how soft the tire is with no inflation pressure. I can literally push it in with my fingertips. The vertical rate is really soft. It also has soft lateral rate. The rim would actually move if I pushed in the rim face. And if you rotate the wheel, you can actually rotate the hub somewhat independent of the tire. It actually would flex. This is important when you're tuning tires and looking at tire pressure. The primary function of tire pressure, besides actually supporting the tire to prevent failure, is to allow you to tune all of these rates. So, as you increase tire pressure, you increase the vertical spring rate, which makes the car act like it has stiffer springs in it. You also increase the bending stiffness of the tire, which you see as cornering stiffness. Increasing inflation pressure will also increase the stiffness of the tire from bending due to camber. So it's important to look at camber sensitivity, cornering stiffness sensitivity, and vertical spring sensitivity to tire pressure when you're trying to think about what tire pressure to run. Now, the issue with tire pressure in race cars is that the tire pressure listed on the door for your street car is probably way too high to actually race on. And I would say for most Champ cars out there, you're going to find that the tires will need between 32 and 40 psi hot. Now, tire pressure does change with temperature, so again, this is a target for the tire pressure after you've been running for at least 20 minutes. Your tires are constantly changing as you drive on track due to thermal cycling. Tire pressure, for example, again, is set via hot pressures, but to reach those hot targets, you will have to start with less pressure, because as the air inside the tire gets hot, it will expand and raise in pressure. If I'm trying to reach a hot target of between 32 and 40, your cold pressures will need to be somewhere between 25 and 30 for most cars. That information you require on your own through empirical testing by going out and running a few laps, figuring out your hot targets, and then through a series of races, figuring out what cold target will get to that hot target. Tires also change their grip level based on the temperature that's on the surface of the tire, which is important when you're driving, because you'll find if you overdrive the car, you actually will get the tires that we run outside of their thermal range, and they will actually begin to lose grip. And this happens at a much lower temp than race tires or our compound tires do. And it's one of the reasons why finesse and finding the limit as to how fast you can drive without excessively heating or slipping the tires is an important part of success in the ChampCar series. Wide tires. Why does everybody run wide tires? Well, one of the main reasons to run wide tires is if your car is experiencing issues overheating the tire, a wider tire will act as a better heat sink to dissipate that heat to the ground. Another advantage of wide tires, the wider the tire, as you're running across the imperfections in the road, the greater the chance that a significant portion of the tire will actually cross on a good section of asphalt. Wide tires do have some drawbacks though. Wide tires weigh more. Wide tires also cost more. On cars done incorrectly, wide tires can lead to increased hub and bearing loads if it requires a rim that will have a center line that's further out than the OEM wheel. You can also mess up your steering geometry or the rest of your geometry by using an incorrect wheel offset because you were trying to fit wider tires in the car. So those are considerations to think about before you go out and just buy the widest tire that can possibly fit. Camber. You probably heard guys talk about camber and setting up their race car. Negative camber is tilting the tire in. Positive camber is tilting the tire out. Why do we add camber? As we talked about before, tires are springs. And when you go through a corner, the tire will actually deflect relative to the rim because it's soft. When the tire deflects outward, if we're turning left right now, you'll have an increase in contact pressure on the outside of the tire. Meaning, if you were to draw a shape of where the tire is touching the ground, it would contact more of the ground on the outside and less on the inside. For this reason, most cars run negative camber. Tilting the tire inward evens out the contact surface where the tire meets the ground and makes it more smooth, more regular. Ideally, you'd have roughly regular or equal pressure inside and outside. To achieve this on most cars, you have to add between 2.5 to 4.5 degrees of negative camber in the front. That will depend on the car you run, and a lot of it will depend on the camber compliance for the car you run. Now, camber compliance is how much camber your car loses from the lateral force being applied at the hub. And you usually see that from soft joints, you can see it from worn out ball joints, you can see it from hub deflection or bearings that have deflection or loss. But that's the difference between your camber setting when you're sitting still, and if you can measure the camber while the car is mid-corner and rolling, it would be less. Another important consideration when you're adding camber to a car is that the camber depends upon the inflation pressure of the tire. As you add more inflation pressure to the tire, the spring rate of the tire gets stiffer in every direction, including lateral. The amount of camber you need is dependent upon how much the tire deflects. So if you increase the inflation pressure, the amount of camber you need will drop. Toe settings work almost like camber settings. You tow an axle in a car to preload the tire in that direction, and the amount of tow the car will need can depend on the inflation pressure, just like camber does. Some cars need toe out, some cars need toe in. In general, most cars run best with toe in the front and 0 to very mild amount of toe out in the rear. But again, this depends upon your particular geometry and which way your geometry actually flexes when it's loaded. Tire balancing. Some people do it, some people don't. My take on tire balancing is you either have to do it right or you don't do it at all. I personally do not balance my tires. On the Neon, the tire diameter is not particularly large, and I've found that for the rims that I run and the tires that I run, they're actually balanced pretty well from the factory. But what is balancing to begin with? So to balance a wheel and tire, the tire is put on a machine that spins it. It measures a low point where the tire needs to have weight added to make it balanced, and then the tech will install a weight, either a clamp-on weight like this wheel has, or a stick-on weight inside the rim. Now, if you choose to add weights to your wheel and tire and have them balanced, it's very important to clean your rim if you're going to use the stick-on weight style, or to make sure that they have the clamp-on style if you choose to go that route. If you stick on the weights on the inside of the rim face, make sure your wheel is clean. This one's not. We also recommend you use Gorilla Tape to tape over your weights to make sure that they do not come off. The one thing you have to absolutely make sure you do not do though, make sure if you're not running wheel weights and you were previously, that you actually take all of the weights off. I helped a team one time that had a wheel balanced and it was balanced incorrectly, and it had an enormous pile of weights in one corner. We simply removed the weights, and although the tire was not balanced perfectly, it was capable of finishing the weekend, and the vibration was not particularly terrible. So again, you can balance tires, you can not balance tires, but whatever you do, if you put weights on the wheels, make sure they stay there. So, look at your tires. How do you determine if you need to make a change to your car? Well, ideally, your tires will come back looking mostly like this. This tire has pretty much even wear across the entire face of the tire. You can see some rolling over of the actual tire material in grooves, but not a ton, indicating that the temperature range of the tire was actually pretty decent. We didn't overdrive so much that we cooked it to death. You also will not see any feathering on the edges, which will look like rough spots that have been curled back. If you can, that's what you're looking for. Now, unfortunately, it doesn't always end up that way. One of the common issues people run into is flat spots. This is a flat spot. That's caused from locking up the brakes. And the issue with flat spots is, one, they shake the car to death. You feel like you're going to lose your fillings in your teeth. But two, once you generate a flat spot, you're more likely to lock the wheel up again in that location and make it worse. And you'll continually have problems locking up the wheels, and you'll end up, like this tire, actually consuming that corner of the tire, while the rest of the tire still has reasonable tread left. So again, if you flat spot the tires, you need to coach your drivers around not flat spotting them, and I would strongly consider swapping tires if the flat spot is great enough that the drivers can really feel it during a race, simply because you will eventually consume that tire, and you could, in this case, we actually lost air pressure and had to pit for fear of blowing up the tire. Another issue with tires you can run into, earlier we talked about camber. This tire lacked enough camber. You can see on the outside edge of the tire here, it is completely bald. The inside edge of the tire, although it shows some heat checking and issues, has a lot of tread left. Looking at this tire on a car, I would automatically suggest that somebody needs to add camber immediately. Another issue on this tire, you'll see flat spots on the inside edge. That's the actual feathering people talk about when they say that they get feathering from toe. Now, you can't always tell if the feathering happens from toe in or toe out, but if you see these almost clamshell shaped divots on the inside edge, you need to check your toe because it is not right. This tire also, as you can see, these big rolled over lips. This tire got really hot. We drove the snot out of this thing. Now, I think if I remember correctly, this was a short race and it didn't matter, but the tire wear would go through the roof if you get it this hot to where you're rolling the tire over that much. And some tires can actually delaminate from excessive heat, especially on the sidewalls. So again, don't do this. I don't have a tire to show the last issue, but if you're on inflation pressures that are too low and your drivers drive the car way too aggressively early on in the race, usually on the start of the race, you can actually fail a tire by blowing out the sidewall. Sometimes the tires will actually chunk and you'll see pieces of the tire missing in a somewhat regular pattern around the outside of the tire. But the key there is when you're driving on cold tire pressures, you need to try to avoid wheel slip if you can until you get the tires up to temp. It doesn't mean you have to drive really, really slow. It just means you can't drive 100% balls to the wall. So again, if you see chunks of your tire missing, especially early on in a race, you may actually run a higher inflation pressure, which may lead to a higher hot target than is optimal for your car, or change out to a cooler headed driver to start your race. Wheels. We all need them. ChampCar allows you to buy wheels up to 2 times the cost of an OEM wheel. This actually gives you a lot of room, and there are tons of wheels available for most cars that fit under this rule requirement. There are 2 materials that most wheels are made from that we race with in this series: steel and aluminum. Steel wheels are generally only made one way, and that is with a spun outer, an inner that is stamped, and a weld that attaches the 2 together. Steel wheels have the advantage of being cheap typically. This one was about 60 or 70 bucks. Steel wheels also can survive light impacts better. You can bend them back, or you can fix some small dents on the actual bead surface. And steel wheels on some cars can offer a ton of offset options, which allow you to package them easier, especially if you're going much wider than your stock wheels. Some steel wheels are really heavy, and so you have to be careful when you shop around and look for these. And steel wheels are not available in every size either. They're available for a lot of sizes that are typically raced on dirt track or other circle tracks. There are some front-wheel drive Econo classes that offer a ton of options that you could find for wheels, but not all cars are going to have availability. Aluminum wheels that we run are typically going to be cast or forged. You'll find a lot of OEM wheels are actually forged or at least cast from a really good material or done fairly well. You have to be a little bit careful when you're buying eBay wheels, because some cheap cast eBay wheels can be prone to cracking, can actually break. So buy from a reputable name, ask somebody else, ask somebody online. Try to make sure you're not buying a really, really low budget wheel. And I've actually found success with buying wheels that are replicas of OEM wheels and using those like the Corvette wheels I run on the 230 SLK Mercedes. So how do you make sure the wheel you buy is going to fit your car? Well, the most important thing first is to make sure it actually will bolt onto your car. And you need to make sure that the bolt pattern for the wheel you're buying matches the bolt pattern for the car you have. Now, Tire Rack can be a great source for this. Most of the internet can give you advice as well, but you need to know whether you have 5 lugs on a 100 pattern, 5 lugs on a 120 pattern, 4 lugs on a 100 pattern. Whatever your car has, you need to match it with the wheel you buy. You also need to match the register on the inside of the wheel for the hub. Looking at this hub, you can see the register here in the center. On this wheel, you can see it fits and clears. And actually these wheels have a much better and bigger register than the hub has. Another consideration, you buy your rims for the tires you want to run. So when you're looking at what rim diameter to get, step one, you have to pick out a tire size you intend to run. So after you've decided on a rim that will bolt on, you need to decide on a rim that has the section width allowance and is the correct diameter for the tire you're going to run. Tire Rack also gives recommendations for the rim width compared to the tire you're running. I would say in general, if you can go on the wider side of the rim for the recommendation, it'll be slightly better. But you need to at least meet that requirement. The other thing to think about, backspacing or offset. Now those two terms are somewhat analogous, but they actually measure a slightly different thing. So backspacing would be measuring from the surface of the rim, the inside surface, down to the hub surface. Offset measures the width of the rim, measures the back spacing, and the offset is how far off the surface that matches to the hub is from the center line. Unfortunately, most wheels are listed in offset. I personally think a back spacing is a much better number to use because typically the things the tire or the wheel are going to hit are on the inside of the car. But again, you can use either number, but know what you need and buy what you need. How you attach your wheels to your car? Well, we use, on some cars, a lug nut. On some cars, a lug bolt. This is more popular in German cars. An important thing to think about when you're buying wheels is to make sure that you get the correct fastener for the wheel you're running. For most wheels, not a problem. Most of them have the same taper. However, steel wheels actually have a 45-degree taper lug nut, which is unique to really old cars and steel wheels. So if you buy steel wheels, make sure you get the correct lug nut. If you're running aluminum wheels, run the right lug nut. It's very important you get this correct because otherwise the wheels will loosen up and you will either get a loose wheel that makes it very hard to drive or you'll lose your wheel. Another thing to think about, wheel torque. I torqued my wheels once for the start of the race and never again. Some guys torque them hot. More importantly, everyone needs to torque the wheels with a torque wrench. Figure out what setting your car has from the factory. I would stick to that. When in doubt, use 80 foot-pounds. But make sure you're torquing them evenly with a torque wrench every time you take the wheel off. Make sure somebody double checks it if you can't remember who did it. And if you do check them hot, make sure that the torque setting on your torque wrench is not excessively high or you will snap off your lugs. Hub-centric versus lug-centric. You've probably heard these terms before, but what do they really mean? Well, this steel wheel and almost all steel wheels are lug-centric. And what that means is that the hub receiver that we spoke about earlier does not actually touch any feature on the wheel. So if I insert this hub into the wheel, you can see that it actually is capable of moving up and down. Now, what actually centers the wheel? Tightening the lug nut does. On lug-centric wheels, it's important to, one, get the correct lug nut for that wheel, but two, to make sure the wheel is free to spin while you're tightening it by jacking the car up. You run the lug nuts on by hand, and then you should tighten them a little bit, move the wheel, tighten them again. What you don't want to do is have the wheel preloaded while you're tightening the lug nuts, because then it will actually be difficult for the lug nuts to forcibly center the wheel. An alternative to that, and much more popular for OEM cars, is wheels that are hub-centric, that have a receiver actually machined in them for the hub receiver to actually go into. These wheels can be tightened with some pressure on them. They can be tightened without rotating. You can tighten one lug nut really tight first and then tighten the rest. Hub eccentric wheels are more forgiving although you can definitely use lug-eccentric wheels if you take the right precautions. After you race your wheel and tire combination, whenever you're ready to replace tires, or anytime it's convenient, you should inspect your wheels to look for cracks. Now, on this cast wheel here, you should inspect the inside surface for cracking in this wheel because it's a dual pattern in between the two patterns, but in general in the area that the lug nut will seat against. Look for cracks there. You should also look for cracks on the edges of the bead. If you have the tire off, on the inside at the edge of the bead. And also on the inside of the rim where the webbing meets the shell of the rim and the hub of the rim. Those are the most likely places to have cracks. You need to clean the rim so you actually can see what's going on. And when in doubt, most of the wheels are so cheap, throw them out. Steel wheels are a little bit different. Steel wheels are less likely to crack in the first place. But if they are going to crack, sometimes you'll get cracks through the section where the lug nut tightens down. You also can get damage that doesn't cause any cracks in the lug nut seat area, which would require replacement, or egging out of the lug nut seat section, which will also require replacement, or else your lug eccentricity will be thrown off. These wheels generally don't crack, but same location. Look on the edge of the bead for cracks. If you dismount the tire, or when you dismount the tire, look for cracks on the inside of the bead edge there, and look for any cracks or concerns where the weld combines the shell with the pressed center. So you got that killer deal on a set of wheels that have the wrong offset, or you have a car or a killer deal on a wheel that has the wrong bolt pattern. What do? Well, you can run a spacer if the wheel just has the wrong offset. This is a spacer, and it simply goes between the hub and the wheel to move the wheel further out. Now, like we talked about before with wheel offset, you can potentially increase the loads on your hub and bearings and cause geometry problems, but if you've done your homework and you need to move the wheel out to get the center of the rim in the right location, this is a good option. If you run really large wheel spacers, make sure that you check your wheel torques regularly, and always use good studs when you're using wheel spacers, ARP or something equivalent. Wheel adapters. I do help a team that uses a wheel adapter. In general, ChampCar frowns upon wheel adapters, but I would say the bigger concern is don't buy wheel adapters that are poorly made or poorly done. So get a quality wheel adapter like this, made from 6061. Make sure you use high quality studs. And when you're looking for wheel adapters, make sure the wheel adapter is thick enough that you can provide a lot of material between the two patterns. Done poorly, wheel adapters can be a disaster. Done correctly, on cars like our Mercedes, this can be a viable option to go from a hard to find Mercedes pattern to an easy to find GM Corvette pattern. When you're using wheel adapters, make sure that you torque the inside bolts to the spec and check them regularly. You also need to make sure that when you remove the wheel adapter with the wheel on, that these studs don't spin. If these spin, it's a nightmare. You have to cut the wheel adapter off or break the rim. The way you avoid that is by getting a wheel adapter made with the correct knurl machine into it, and using the correct stud, and using some green Loctite to connect the two together. A couple final points for picking out a wheel. In general, for a given tire, if you go wider with the rim, it will actually deflect less, and you can run a lower inflation pressure, which for most cars will give you more grip. If you're stuck between two wheel sizes to pick from, a taller rim or a shorter rim for the same diameter tire, I would generally go for the smaller rim. And that's because it gives you more options to tune tire pressures, because you can change the rate of the tire more with tire pressure. Main consideration of rims though, pick the rim that fits the tire you intend to run. That concludes our sections on wheel and tires. Make sure you like and subscribe. Please post any comments or questions. We'll get to them when we can. Thank you again.